Have you ever played a video game and wondered how the world seemed infinite? It seems like the adventure never ends. No matter how far you travel, you'll find something new in every direction. Take Minecraft, for example. Whether it's a mine shaft or a desert temple, the possibilities are endless. There's actually a reason you can explore the game endlessly. It's called Perlin noise. Okay, but what do I mean by noise? My game isn't exactly yelling at me. Throw out your initial thoughts about noise. The noise we're talking about are math functions used to generate random numbers in computers. They are often used to add variation in computer generated content, like terrains, oceans, forests, bodies of water, clouds, and any other visual effects in video games you can think of. Using a noise function to randomize your generated landscapes is called procedural generation. Generated content lightens the workload of developers and designers by allowing their assets to be randomly generated on a large scale. This way, they don't have to spend hours creating every single piece of land that a player sees. We don't need artisanal grass, we can just generate it to save time. Well, how does it not look like a jumbled mess? Perlin noise gives off what we call a gradient noise effect. Instead of a random value for every point, it uses a smooth, continuous wave pattern. The trick is that, for any 2 points, the further they are from each other, the more their values are allowed to differ. Here's how it works. Let's take a grid with randomly generated unit vectors, illustrated by the green arrows. By definition, a unit vector means length of 1. It's meant to represent pure direction without affecting scale. Now let's zoom in and try to sample our first texture. I've chosen a random pixel point to sample our first value. Now we are going to calculate the distance vectors. This is called displacement, and it calculates how much the pixel is influenced by each gradient. If we take the dot product of these two vectors, we will get a value that represents how aligned the two vectors are. If they point in a similar direction, you will get a higher value, and if the vectors point further away from each other, you will get a value that is closer to 0. Using the values calculated, we will perform cubic interpolation, which will give us our exact pixel value. This process is then repeated across our grid, eventually resulting in our panel of Perlin noise. However, Perlin noise isn't singular. You can't just use one instance of it, or it would be too blobby. It's inherently smooth and low frequency. Creating large, rounded features like hills or clouds is easy, but difficult textures are a little harder. To add realism, multiple layers called octaves, which is just Perlin noise panels with different frequencies, are added. This creates what we know as fractal noise, which looks much more complex and natural. For developers, they'll use this noise to simulate procedural terrain, like how Minecraft utilizes it. They map their assets to certain parts. So, for instance, darker sections might indicate an ocean, while brighter sections map to land. Now that you know about Perlin's noise, maybe you'll stop trying to search for the edge of the world. But hey, if you want to explore endless generated content, be my guest. Thanks for watching.